Hey guys, today we are looking at 1.5, which is solving literal equations. It's a very fancy way of just saying that we are going to be rearranging equations for a different variable. These ones are going to be a little bit different because we're going to have multiple variables in our equations, but other than that, it's going to be the same skills we used in 1.1 through 1.3 for solving equations in order to get those variables by themselves. So where this is going to be really useful, we'll have equations eventually down the road in this class, especially next year when you guys are in geometry, or some of you are already in geometry as well. They're going to be really useful when you start getting into those surface area and those volume problems where you've got multiple different variables in your equation. If you can rearrange those equations to solve for a different one, it'll make your life a lot easier for some of those calculations you may have to do. So, like for example, in what we're looking at here, for instance, the perimeter of a square, we know that equation is P equals 4s, so 4 times however many sides you have, or the length of your side. That's how you get your formula for that. But if you're doing a lot of problems where you know the side length of your triangle already, or your square already, and you're trying to find the perimeter, or vice versa, if you're working backwards, you know the perimeter, but you're trying to find the side length of that triangle or that square, you could rearrange this equation to get s by itself instead of having p by itself. That would be something that's useful for us in those types of equations. So we're just going to go through a couple of examples together, just kind of walking you through. This first one is already done for us. You can see I have the steps that we're doing over on the left side, and then the explanation for what those mean, what the actual thing I'm doing is. So in this one, we're solving a linear equation, ax plus b equals c, and we're asked to solve for x. So whatever we're asked to solve for here, that's the variable we're trying to get by itself. So everything else is going to get pushed over to the other side, just like if it was numbers in there. I'm trying to get x by itself. And the steps that we're doing, the process is still going to be the same. I'm still getting whatever's not attached to my x away from it first. So in this case, we're adding b. I'm going to go ahead and subtract b from both sides because that's the inverse operation for addition. When I do that, the thing that's going to be a little challenging for us to get used to is the fact that once you move those things over there, I'm not going to be able to combine like terms. Because b and c are two totally different variables. I can't add those together because I don't know what those numbers are that are being represented by b and c. So you're going to have to leave those as they are. Next step, since a is multiplying by my x, I'm going to go ahead and just divide by a on both sides. So dividing by a on both sides, that will reduce my a's over here, kind of the same thing that happened with my b's. And now I just have x on the left side. But again, since I can't reduce my a's, b's, and c's, those are all different variables, I just have to leave it as is. C minus b, and all of that is being divided by a. So your answers for these problems are going to be a little messier, but the good thing is it's just the same steps, the same process that we're doing. So if we take a look, example 2 is another one that is something very likely that you would see in geometry next year. Maybe you've probably even done some area of a triangle already in middle school. If you were doing a bunch of problems where you knew the area of the triangle and you knew the base of the triangle, but you were trying to solve for the height, rather than plugging in your numbers for a and b and then having to solve your equation for h every single time, it could be more useful to you to rearrange this equation so that h is the isolated variable, so you could just plug in the area of your triangle and the base. So the way that we're going to do that, since we're solving for h, is anything that's not attached to h, we're going to move over. So you can see here, I already listed what steps I'm going to do first. And really, these first two steps could be done in either order because both of these things are just multiplying h right now. So they're the same operation. So I could multiply by the reciprocal of 1/2 first and then divide by b. But since that's already written here, we're going to go ahead and just do that. So step 1, move b by division because h is being multiplied by b. So if I divide by b on both sides, those cancel out there. I have a over b equals 1/2 h. And then from there, I'm just going to multiply by the reciprocal of 1/2. Or if you're a fancy person and want to say I'm dividing by 1/2 on both sides, That's fine, but in order for it to be simplified, I'm really going to be multiplying by the reciprocal. So times 2 over 1 times 2 over 1. Because those, my 2's and my 1's cancel out, I'm just left with h all by itself on one side. The other side, 2 times a over b, ends up as 2a over b. So that's the rearranged equation. If you had the area of your triangle and the base of your triangle, that formula would allow you to find the height of that triangle directly. Moving along to the back side, some application problems. Again, these are kind of, they're options for you on whether you rearrange these first or not. In this case, just for some practice, it's going to be something that we're going to do. If you're in physical science right now, you probably have or will be seeing some DRT problems. Distance is rate times time. That's a pretty common problem when you guys start talking about rates and speed and velocity and stuff, or in physics eventually if you take that with me in a year or two. So for this one, Brandon knows that his truck route from Illinois to Tennessee is 430 miles long. He also knows that distance is your rate times your time. How long will the route take if he averages a speed of 50 miles per hour? So we're going to start first by solving that equation for time, because we know the rate and we know the distance. So if we rearrange this equation first so that we have t equals, then we'll be able to plug stuff in a little bit more simply or more directly. So here, if we're trying to solve for t, our first step to get t by itself, it's being multiplied by r. So I'm going to go ahead and divide by r to move it. So those cancel out over on the right side. So d over r, so your distance divided by your rate, is equal to your time. From here, since it's a word problem, we're actually going to be solving for those things. We're going to then go ahead and substitute in there the distance from Illinois to Tennessee, 430 miles, and then the rate that he's driving at, which is 50 miles per hour. So we're going to plug that in there for r. When we do that, 50 dividing 430, so 430 divided by 50 is 8.6. So 8.6 hours is how long it would take Brandon to drive from Illinois to Tennessee. All right, last problem that we're going to do together, this last application problem, is not a perfect one. It's not as realistic for us to do, but still a kind of more interesting, different one. For this one, we're told that shoe sizes and foot length are related, which is true. The bigger your foot, the bigger your shoe size has to be. But they're claiming that this formula, your shoe size is 3 times your foot length minus 24. Where S represents your shoe size and F represents your foot length in inches. So if you could measure your foot, you would multiply that measurement times 3 and then subtract 24, and that theoretically is your shoe size. If you were trying to find a rearranged equation for this, where if instead you wanted to just try and estimate or find how long someone's foot was based on what size shoe they wore, you would be able to rearrange this equation to get F by itself so that your answer would be your length of the foot. So in this one, first things first, since we're trying to solve for F, you can already see here, my first step is going to be adding 24 to both sides. So we're going to go ahead and add 24 to both sides. That gives me S plus 24 equals 3F, because those cancel out right there. Next thing, if we're trying to get F by itself, we're going to go ahead and divide by 3 on both sides. So all the way across, that's going to give me F equals S plus 24 all over 3. And you can leave it like that. That's perfectly acceptable, and in most cases, I would say don't even bother with what I'm going to do next. But if you want to, for those that can see this, because 24 divided by 3 is a whole number, what you're allowed to do is take this equation, come on, pen, there we go, and split this up. If you have a polynomial, so if you have some like 2 terms being divided by a single thing, you are allowed to split it up to S divided by 3 plus 24 divided by 3. That's only allowed if you have something that's being divided by a single thing. It wouldn't work the other way around. If it was 3 over s plus 24, you couldn't split that up into 3 over s and 3 over 24. It's only when you're dividing by a single thing. So in this case, the only reason I would want to do that is because then my equation, maybe, depending on your personal preference, is a little more simple. S over 3 plus 8. So you take your shoe size, divide it by 3, and then add 8. So for this last piece, they don't ask us to do anything, but just for fun, let's just pretend that we wanted to estimate how long your foot is based on your shoe length. So we'll just use mine as an example. Depending on the brand and stuff, I'm usually around a 13 or a 14 shoe size. So if I was going to just use 13, if I was going to estimate that, I wanted to figure out how long my foot is based on that I wear a size 13. I'm going to go ahead and plug in 13 in here for S, and then divide by 3. So I'm going to use the original one. So 13 plus 24 is 37, all over 3. So I am estimating, based on the equation, that my foot is just over a foot long, 12.3 inches. And you can try that with anyone's. If you wear a size 7.5 shoe, you would plug that in there. 7.5 plus 24 is 31.5. Divided by 3 tells you that if you're wearing a 7.5, your foot's probably about 10.5 inches. But that's pretty much it for today. So that's all I got for you. The homework tonight is on page 40. You guys are doing 3 through 12 all. So it's a little bit different. You're not doing the evens. You're doing both evens and odds, but 3 through 12 all. As always, make sure you guys come ready to ask questions if any of this confused you. If you want to get a head start on the homework so that you're ready to ask those questions as well, that's a great idea. But that's all I got for you. So I will see you guys tomorrow. Have a good one.